Lesson 11.3. Well, let's get started on this Bellringer over lesson 11.2 when we were just looking at probability distributions. Number 1 says a sample of high school students were asked how many days they overslept last week. Use a frequency distribution to shown to graph the probability distribution for the random variable x. Well, before I get started here with this table, I'm going to encourage you to go open up your Desmos pre-programmed calculators, which I have here. And from this document, if you slide down to the bottom, open up your statistics calculator. So oftentimes in younger levels of math, I'll call it younger because we got there when we were younger students, we saw a table and we would immediately type these in as x and y. Well, what we've been doing the last few classes, we haven't exactly been dealing with this data right away. We've a lot of times been altering it first. And so on this particular problem, what I'm going to do is find the probability of each occurring. So the oversleeping 0 minutes, what's the probability of that? What's the probability of 1 minute? And all that value, all those values going down. And so just to help me see this a little bit clearer, let me add some lines in here. And what we need to do is come up with the sum. So we could use the calculator or even just to add them across. 12 plus 18 is 30, plus 10 is now 40, plus 7 would be 47, plus 11 would be 58, 61, 70, 75. I believe we have a total of 75 here. And so if I have my values correct as we go across, the probability of each one would be like on this first case, it would be 12 divided by 75. This one would be 18, whoops, 18 divided by 75. So this right here, the sum I got was 75. And so if we just went down, hopefully it did in fact equal 75. 30, 40, that would be 47. That would be 58. This would give us 61 again. If you were calculating the sum, 9 gives us 70, and 5 more gives us 75. Okay, so if we've done this right, the probability, the sum of this should equal 1. That would be the probability. Okay, so let's look at how this graph is. So instead of graphing the values they gave us, we're going to graph these. So oversleeping 0 minutes, 1, 2, 3, 4, 5, 6, and 7. We're going to look at those, and specifically the probabilities. It's 12 over 75, 18 over 75, 10 over 75, 7 over 75, 11 over 75, 3 over 75, 9 over 75, and 5 over 75. I'm going to hit the little zoom fit button right here, and we can see our data. Now here's the deal. It shows it to us as continuous data, this line here. But truthfully, what we were not looking at is if you overslept 1.5 minutes or anything like that. It was just rounded. It was shown as discrete. So you could actually edit this if you wanted to. If you hit the setting, you could change this value right here. Whoops, why isn't it working? There we go, edit. I'm going to click this value, and you could turn off the lines like this. You turn it off and you see just the dots. The point is like that, but I like the lines on there just to help me see this value a little bit easier. But ultimately, this needs to be discrete data. So if I were going to use these values and try to come up with the solution, it would be helpful for us to look at the answer choices. So here on this slide, I have the 4 answer choices, and I know this line graph appears really good. But again, this would be as if it were, these are the number of days, how many days they overslept. And I think I was reading that as minutes earlier, but this is how many days of the week they overslept. And you can't oversleep 1.5 days. So this would actually be out because that is continuous data. So this one is out because it's continuous. Even though it looks like our graph, we should be continuous. Okay, there we go. That's why this one is out. So we're really looking at these values. And now the probability, remember all probabilities have to add together to be 1. I can see that this chart, these values do not equal 1. Sum is greater than 1. So C is out. And when we look at these probabilities, okay, so now we're looking between these two. And we want to find the exact probability. It looks like to me that it would start at a little bit above 15. That's a little bit above 15. Ooh, this one's not. This one looks like it's just the number 12. They put that at 0.12. So that's value is going to be off. That was right here, 0.12. My guess is this one is going to be 0.18, and it is. You can see what they did on this incorrect answer is they just plotted the frequency as a decimal rather than actually calculating the probability. This looks like it's 16%, which I didn't even write it that way earlier. We could have come back and said, okay, that must be 16%. This one would be 24%, and so on and so forth. You could get all the values just by clicking through here. This would be 13.33%, 9.33%. Maybe I shouldn't, I speak too early. No, that was 24, that was 16. Okay, I just happened to get the decimals down. 4%, 12%, and 6.67%. So that's how you can do number 1 using that calculator. Now, let's talk about number 2. It says, find and interpret the mean for exercise 1. Well, we talked about last class quite in detail about the math involved to find the mean. But what I did not tell you is now that we're here, I'm going to go ahead and let you know, you can on Desmos type in mean. And what I'm going to do on here is, let's see, the mean of this data here. The mean, you can type in, actually, that's not going to work yet. Let me first come back over and show you the algebra here. So let's go back to the algebra. If you remember what it is, the way you determine the mean is you multiply the x value times the probability p of x. Let's write that in here. This is probability p of x. So what I could do is I would come in here and say, this is the expected value, is what we're trying to solve. If I did x times p of x, what we would get is 0 times this, which is 0 here, and then 1. So this is my x, and I'm multiplying it times the probability p of x here. 1 times this is 18 over 75. 18 over 75. Sorry about that. Pen problems. And now the next. Whoops. Okay, let's try this again. And then 2 times 10 over 75 is 20 over 75. 3 times 7 over 25, whoops, is going to be 21 over 75. And then over here, 4 times 11 over 75 is going to be 44 over 75. 5 times 3 is 15, so that's 15 over 75. 6 times 9 is 54, so 54 over 75. And finally, 7 times 5 is 35, so 35 over 75. And now the mean we learned, the mean is equal to the sum of the x times the probability of x, the expected values here. It's the sum of these expected values, or the expected value itself is the mean. And so if I add these up, and that will be our mean here. So I'm going to come back to this in a second. So what do I have? And I'm going to add this as a new list. Let's just call it M1. So the expected, I have 0, 18 over 75, 20 over 75, 21 over 75, 44 over 75, 15 over 75, 54 over 75, and 35 over 75. How many lists here? There's 8 total. From 0 to 7 is 8 total. So there's 8 total here from 1. And here's a trick, the length of x1 So that means it's just going to run all these numbers in here. And what do I want it to add up? I want it to add up the M1 list. So you type N1 and then you do this little N like this. And it says the mean is 2.76. The mean would be 2.76. That's the expected value, that a student would oversleep 2.76 days in a week. So let's come over here. 2.76 is answer choice C. And the standard deviation, which we can go through the algebra for, but again, there's ways of doing this in the calculator that would be much more beneficial. All right, now let's talk about how using the calculator we could come up with these values. Now there's little codes here that you could type in, like mean of y1, for example, and it'll give you the average of this data set. But if we don't have the data set up there, you'd have to do a little trick. And so what I'm going to do here is walk you through. We found the mean by finding the sum of all these different probabilities. And I called that M. I probably, now thinking about it, would have been wiser to call it P, probability. Let's call it probability. And so I need to change this now to a 1. And so that was our mean that we found. Now, if you wanted to find the standard deviation, or rather, let me start with variance. If you wanted to find the variance, if you remember the formula, you have to take your random variable and subtract it from the mean. You square that value, and then you multiply it times the probability. So now that we know the mean, you take 0 minus that, and you would go all the way across here. I'm going to let the calculator handle this for us. This would right here equal the variance, which is sigma squared. So that's our formula. Here's what I'm going to do. I'm going to come over here and basically type in the same thing here. Let's have sum, and we're going to go from 1 to the length of x1. That means it's however long this list is, it's going to continue to add the sum together. And what we're going to do is we're going to subtract the x1 value, x1, and here's how you work with lists. You use this bracket here, and I'm going to put the letter N. That means it's going to plug in, when N is 1, it plugs in there. It says, what's the first number in the list? And then it'll plug in the second and the third. The reason it's 28 is because it's 0 plus 1 plus 2 plus 3. It's adding those all together. What I'm going to do is I'm going to take that value, and I'm going to need to subtract it from the mean, which we got the mean to be 2.76. So each value minus, oops, I put 2.76. There we go. And now we need to square this. And then we're going to times it with the probability, which is P1 of each value. And I get this as my variance. My variance is 18.76. So if you needed to know the standard deviation, you would take the square root. The square root of that 18.766976. That's going to be our standard deviation. And so when I come back over here, it looks like my values are a little bit off. Let me check what I did wrong with my formula real quick. Very simple mistake here. That was not supposed to be the probability. This was the probability here. So when I come over here, I need to name, there we go. Now I have that as my variance. I'll call it V. And then I'm going to take the square root of that variance, and I get 2.2. So very simple mistake I had there. I can check it. The sum of my probabilities is 1. That's good. This right here, to find the mean, needs to be a 1 again. So there's our mean. Okay, so that was my problem, is I wasn't multiplying times the probabilities. I was multiplying times the expected values when we were calculating that. Now I have my numbers right, 4.93 and 2.22 for my standard deviation and variance. Variance and standard deviation in that order. The symbols one more time. Let me go ahead and write this over here. That would be my variance symbol right there. My variance would equal 4.93. 9 to 9, and I'm approximating. And so the standard deviation is the square root of that, which is approximately 2.22. And let's take a look at now number 3. It says, which situation describes a binomial experiment? Now, in binomial, just remember that means there's 2 outcomes. No matter what, there's only 2 outcomes, and you perform an experiment a whole number of times. So let's see, I toss a coin 10 times, so that's a whole number, to see how many heads occur. Well, if you toss a coin, there can only be heads or tails. That sounds pretty binomial to me. 2 choices. There's either heads or it's going to be tails, one or the other. So this one looks pretty good. Let's check the other one. You ask a friend how old they are. Well, if you ask me when I'm making this video, I would say 35. I ask you, you might say 17. Someone else might say 18. Another might say 16. Notice there's a whole lot of options there. So it's not binomial. I try to guess a student's height. Well, I might look at you and say, well, you're kind of shortish. So I'm going to say 4 foot 1 inch. You might say, that's right. Or you might say that's wrong. What do you think? Well, it's either right or wrong. 2 answers. Well, no, because I might guess a different student, say, you're kind of tall. You look kind of like you're 6 foot 11 inches. Well, I can be guessing, and notice I have all these different heights. So no, that's not binomial. Let's see, I roll a die until 6 appears. Well, I roll it and I might get a 5. Maybe I get a 3. Maybe I got a 6. Notice there's 3 different options there. So the answer choice would be A.